Hello, everybody. So my teacher gave us some homework yesterday, not today. Yesterday, she gave us some homework where we had to solve some integrals on a packet, and one of the problems she didn't realize requires a method that we haven't learned in class at this moment. We are going to go over it later, but it is a BC topic, and I'm in AB. But my teacher's nice; she'll go over it later. I figured out how to do it because it's mostly algebra. And I decided I would make this video for AB kids who want to learn how to do it, and BC kids who need some review on how to do it. So, let's turn on the laser pointer. Let's do this. So, we have our two fractions, and instead of adding, we're actually going to do subtracting because I wanted to make this a -5, but same difference. 4 divided by x plus 2 minus 5 divided by x plus 3. The first thing that we have to do in order to combine these is to create the common factor, which in this case will be x plus 2 times x minus 3. So we multiply top and bottom of this by x minus 3 and top and bottom of this by x plus 2. Our top will become 4 times x minus 3 minus 5 times x plus 2. Distribute 4 minus 5 is -1, -1x. -12 minus 10 is -22. That's why we get this result, -x minus 22 divided by x squared minus x minus 6. So now we're going to approach the opposite way, and we're going to use this to know if we got our answer correctly. So partial fractions states that you can split this function into two fractions. In this case, because the lower power is x to the power of 1, our numerator will be something of x to the power of 0 or 1. So a is a constant, b is also a constant. They're not necessarily integers. They can be positive, negative, or irrational. In this case, they're not going to be irrational, thank goodness. And we have our denominators, which would be x minus 3 and x plus 2, which is what we had before. That's just factoring, and that's one thing that will help explain if you get a partial fraction, if you can do partial fractions to it. Now, let's go back to what we did before, where we took this and combined them together. So we get ax plus 2 plus bx minus 3. We're just combining these together. A and b are considered variables along with x. Now we distribute, and what I decided to do was instantly group them together in this fashion. Now we've grouped all of the variables with x on one side and all the variables without x on this side. And here's where the magic begins. So how did I get to these systems of equations? Well, a plus b has to be some number, so this x becomes a -1. Notice how these are this is the only function that is connected to what we have here right now. And because we want to find a specific a and b that gives us -1, as of right now, we have two unknowns, only one equation. Where does the second equation come from? It comes from trying to solve for the second section, which is 2a minus 3b. That has to equal -22, because that is the only thing that is doing stuff related to x to the power of 0. So we have our two system of equations. This governs for x to the power of 1. This is for x to the power of 0. Remember, -1 times x is -x. And here we have a plus b has to equal -1, and 2a minus 3b has to equal -22. If you solve this, you will get a equals -5, b equals 4. We can check that. -5 plus 4, -1. -10 minus 12 equals -22. And if you noticed it already, this is the same kind of math we're actually doing over here. 4 minus 5, negative 1. Negative 12 minus 10, negative 22. So we're just using a system of equations to solve for this different a and b. Now, I'm going to show the example that we got for homework. It's an indefinite integral. It's the integral of 1 divided by 4 minus x squared dx. Remember your dx. So, how would you split this? Well, one thing that you should know is that this is a difference of squares. So one section is going to be 2 plus x, one section is going to be 2 minus x. And because of that, and also because of the fact that we don't really have any other method at the moment to solve this, we instantly know that this should be using partial fractions. So I instantly wrote it as that: a divided by 2 plus x plus b divided by 2 minus x dx. Now let's combine them again together. And we distribute to get b minus a equals 0 and 2a plus 2b equals 1. And this is where I ended up with my equation last time. When I actually did it first attempt, I got it wrong. When I divided this by 2, thinking I could be smart, trying to cancel out the 2's on all sides, I forgot to divide this one by 2 as well. So I got some negative 1/2 and 1/2 craziness. Then I plugged it back in the equation and it didn't work. So I redid the equation. I got a equals 1/4 and b equals 1/4. You can actually check that. 1/4 minus 1/4, 0. 1/2 plus 1/2, because 1/4 times 2 is 1/2. That equals 1. So we are on the right track. Now we can substitute 1/4 for a and 1/4 for b. I'm going to write it like this. It's going to make a little bit of sense afterwards. But now, as you should realize, is now we have two separate integrals. You can split this along the middle. One of the fundamentals of integrals. You can find the integral of this side, which for both of these are natural logs, because it's some constant over a function of x, or in this case x to the power of 1, because otherwise you're going to have to start using u sub, and we don't want to do that right now. So we have our exhibit, which is our 1/4 natural log of 2, absolute value of 2 plus x. Remember your absolute value, except for when this inside function will always be positive, then just use parentheses, minus 1/4 ln of 2 minus x plus c. Just taking the integral of both of these. And in order to solve the actual question on the packet, you had to combine these together using one of the properties of logarithms. The difference between two logarithms is the same thing as the logarithm, the log of the quotient of the two inside functions. So you divide 2 plus x by 2 minus x. This works because of the 1/4, they both share a common factor. So I can just move that over to the side, divide as normal, and this is your answer. 1/4 ln of absolute value of 2 plus x divided by 2 minus x plus your c, because this is calculus. Your constant is always important for integrals, especially the indefinite ones. If you could use this method, add, I don't know, like 4 over here and 3 over here, and then you would be able to solve this integral. So to all the AB kids out there, you don't really need to worry about this unless your teacher is going to teach you it, in which case you should listen to your teacher. I honestly think this is just an algebra concept that just became very important because now calculus actually cares about it. And to all the BC kids, this is very, very important for you guys, so you should find some way to remember this. Well, thank you for listening to how you do partial fractions for calculus. I've made more calculus videos and some lower math videos on this channel. Not all of them, most of them are AB and lower related, not a lot of BC. Like and subscribe, and I'll see you soon. Bye.